The last subtopic of Chapter 7 is 7.3 Solutions of Trigonometric Equations. And in this subtopic, we're gonna have Larka and Liga, T substitution, and R form. Let's start with the meaning of Larka and Liga. So what does Larka stand for? L is linear form, A is alpha, R is range, Q is quadrant, and A is for answer. So we will use Larka in order to solve for sin theta equal to K or cos theta equal to K or tan theta equal to K, where K can be any value. So this means that K can be a positive value, or K can be a negative value, or K equal to 0. So we can use Larka for any value of K. Now, what about Liga? L is linear form, I is interval, G is for graph and then you need to compare the graph, and A is answer. You can also use Liga in order to solve for sin theta equal to K, cos theta equal to K, and tan theta equal to K. But this is for certain values of K only. And we will usually use Liga in order to find the value of X for maximum and minimum values. Therefore, whenever you need to find the value of X for maximum and minimum values, you need to use Liga. By comparing Larka and Liga, you can see that for Larka, we will draw a quadrant. But for Liga, you will draw a graph. And Liga will only be used whenever you need to find X for maximum and minimum values. Let's start with part A, where you need to solve trigonometric equations in linear form. So what is linear form? Linear form means that this trigonometric equation is in this form. Sin theta equal to K, cos theta equal to K, or tan theta equal to K. So linear means that it is to the power of 1. So here you can see that sin is to the power of 1, cos is also to the power of 1, tan theta is also to the power of 1. So this is a linear form. Whenever you need to solve a linear form of trigonometric equations, use Larka. Make sure that your calculations in degree. So if you have radian, change it to become degree. So that's your calculation. But your final answer should follow from the question. If the question says the final answer should be in degree, therefore your final answer should be in degree. But if your question is in radian, that means your final answer should also be in radian. So let's do example 9, question 1, where you need to solve the following. For question A, you have sin 2 theta equal to 1 over square root 2, and theta is between 0 degree and 180 degree. Since range of theta is in degree, therefore your final answer should also be in degree. As you can see, this is trigonometric equation in linear form, where you can write sin theta equal to K, cos theta equal to K, and tan theta equal to K. So this is in linear form. Therefore, we will be using Larka. So we'll start with L, where L is linear form. And this is already in linear form. Sin 2 theta is equal to 1 over square root 2. So we will refer to this linear form in order to find A, R, Q, and A. Next is A, which is alpha. So this means that you need to find the value of alpha. So what you're gonna do is that you're just gonna copy down linear form into A, but you need to change 2 theta to become alpha. So you're gonna have sine alpha. And then here we have 1 over square root 2. So just write down 1 over square root 2. But be careful for this step. Alpha is acute angle. Therefore, it should be less than 90 degree. And hence, alpha is in the first quadrant. Therefore, by using all science teachers crazy, in the first quadrant, you can see that all trigos should be positive. And hence, you should have sine alpha equal to a positive value, cos alpha should also be a positive value, and tan alpha should also be a positive value. And hence, sine alpha here should be a positive value. So, in this step, here should always be positive. Now, we just need to find the value of alpha. So, how to find alpha? If you have sine alpha equal to 0, alpha is sine inverse of 0. Therefore, if you have sine alpha equal to 1 over square root 2, it is actually alpha equal to sine inverse 1 over square root 2. So make sure your calculator is in degree. So just press shift and then sine. So that will give you sine inverse. Shift, sine. So that's your sine inverse. And then we need to put 1 over square root 2. So 1 over square root of 2. And the answer is 45. So this means that alpha equal to sine inverse 1 over square root 2 is 45 degree. So this step is not compulsory. Straight away, you can just write down alpha is 45 degree. Next, we have R, which stands for range. Copy down the range that is given to us in the question. And now let's refer back to the linear form. So here we have 2 theta. So we need 2 theta, but in the range here, we only have theta. So in order to get 2 theta, we're gonna times everything here with 2. 0 degree times 2 is 0 degree. The symbol stays the same. Theta times 2 is 2 theta. And then 180 degree times 2 is 360 degree. So this means that for our question here, we need to consider our quadrant from 0 degree until 360 degree. Next, we have Q, which stands for quadrant. So draw your quadrants and label all science teachers crazy. And now let's refer to the linear form. Here you can see that sine is a positive value. So you need to look at quadrant where sine is positive. And hence it should be in quadrant 1 and quadrant 2. Because in quadrant 1, all trigos are positive. So that's okay, which is in quadrant 1. And for quadrant 2, we know that sine is positive. So you can also consider quadrant 2. But for quadrant 3 and quadrant 4, only tan and cos are positive. So we're not gonna consider quadrant 3 and 4. So draw a straight line in quadrant 1 and quadrant 2. And as per usual, label your alpha. So alpha is in the shape of a butterfly. So here is alpha and here is alpha. And now we need to find A, which is the answer. As per usual, always refer back to our linear form, which is this one. So look here, we have 2 theta. Therefore, here should be 2 theta as well. So we need to find 2 theta. Okay, so how do we find 2 theta? Look at your range. Our range should start from 0 degree, which is here, and then it goes up until 360 degree. So this is positive, means that it is counterclockwise, starting from 0 degree until 360 degree. So let's start from 0 degree. It goes up and then it touch this straight line. Okay, so this is your first answer. So this is your first 2 theta. And to find this line, this is actually 0 degree plus with alpha. So this is 0 plus alpha. And we already know that alpha is 45 degree. So this is actually 0 plus 45 degree, which is just 45 degree. But don't forget that our range is between 0 and 360. So if we continue, we're gonna touch the second line, and this is also 2 theta. We know that this is 180 degree and this is alpha. So 2 theta is actually 180 minus alpha, which is 135 degree. Now let's continue until you reach 360 degree. So if we continue, there is no more line until you reach 360 degree, which is here. So there's no more answer from this one. And hence, we have only 2 answers. But we're not done yet because we only want theta. So, to get theta only, divide everything here by 2. Therefore, theta is 22.5 degree and 67.5 degree. But don't forget to check with your question. Final answer should be in degree, which is this one. So final answer is in degree. And then try to check from range as well. Okay, here theta is these 2 values. So look at theta as well. Theta should be between 0 and 180 degree. So make sure your answer theta here follows the range of theta as well. Okay, so we can see that these 2 values is within this range. So this should be correct.